A box and whisker plot is a visual representation of the distribution of data. And in order to understand a box and whisker plot, we need to remember how to divide data into quartiles. So when we have a set of data and we want to divide that data into quartiles, the first thing we'll do is order the data from smallest to largest. Then, to divide it into 4 equal pieces, we'll find the median of the data. That divides the data into 2 equal parts, in this case with 8 values below and 8 values above the median of 19. And then we'll find the median of each half of the data. So the median of the first half is between 10 and 13, or 11.5, and the median of the second half is between 27 and 29, which is 28. Now those numbers, 11.5, the 19, and the 28, have special names. We call 11.5 Q sub 1 because it defines the first quartile. We call 19 Q sub 2 because it defines the second quartile. And we call the 28 Q sub 3 because it defines the third quartile. Now we're going to take this same data and turn it into a box and whisker plot. So to do that, what we're going to do is relate these values to a number line. We won't actually put all the values on the number line yet, but let's put some other important values above the number line. For example, Q sub 1 is 11.5, so we'll put a dot right above 11.5 on the number line. Same thing with Q sub 2, which is 19, and Q sub 3, which is 28. The 2 other important values to put above the number line are the minimum value, which is 5, and the maximum value, which is 36. The box in a box and whisker plot defines the middle half of the data, in this case from 11.5 to 28. We anchor the median, or Q sub 2, to the box with a line segment. We also anchor the smallest value and the largest value to the box with the whiskers of a box and whiskers plot. Because we divided the data in such a way that 1/4 of the data was in each quartile, we're going to have an equal number of data points in each section of the box and whiskers plot. So there are 4 data points, the 5, 7, 8, and 10, in the first whisker. There are 4 data points, the 13, 15, 16, and 18, in the left part of the box. The median falls in between the boxes. There are 4 data points, the 21, 22, 23, and 27, in the second half of the box. And the last 4 data points, the 29, 30, 32, and 36, fall on the right whisker. So we have an equal number of data points in each of the 4 sections of the box and whisker plot. If we're given a box and whisker plot, but not all of the data, we can still pull some information off of the plot. In this case, we can tell that the minimum test score was a 68, and the maximum test score was a 98. We can see that 78 is Q sub 1, 85 is Q sub 2, and 93 is Q sub 3. Q sub 2, remember, is also the median for all of the data. One last thing that we can tell about this data is how it was spread in the individual fourths of the data. For example, if you look at the first fourth of the data and compare that to the last fourth of the data, you can see that the first fourth is spread a lot further than the last fourth. So since the first fourth was spread further and the last fourth was spread less, we can tell that the test scores in the bottom fourth were a lot further apart than the test scores in the top fourth. The top fourth, the scores were bunched together a lot more. We still have the same number of test scores in each of those fourths, but now we know something about how they're spread out within the fourth.